This is the video introduction to Lesson 18, Additional Resistances with LEDs, in the Mr. Circuit Lab 2. We discussed in Lesson 17 that there is a voltage drop across an LED in a circuit. Some LEDs in our lab drop approximately 2 volts, and others drop approximately 3 volts. You have learned that in a simple circuit, there are 3 factors: the voltage, the resistance, and the current. If we have the value of 2 of the 3 factors, we can calculate the third with Ohm's law. With an LED that has a 2-volt drop with a current of 18 milliamps, we can calculate the resistance that the LED gives to the circuit with the formula R equals E divided by I. Let's try it. R equals E divided by I. R equals 2 volts divided by 18 milliamps, or 18 thousandths of an amp. R then equals 111 ohms. So the amount of resistance this LED is to a circuit is 111 ohms. Let's prove it. If we were to have a simple circuit of 2 volts and a resistor of 111 ohms, how much current would flow? It would equal 2 volts divided by 111 ohms. That would give us I equals 18 milliamps, or 18 thousandths of an amp. So you can see the LED looks like a 111 ohm resistor in the circuit. With 2 volts across a 111 ohm resistor, we would get the same amount of current as when we connect 2 volts across this LED. Suppose you have a 9-volt battery, and you want to know how much resistance you would need in the circuit to cause a current of 18 milliamps, or 18 thousandths of an amp, to flow. Here is the formula. R equals E divided by I. E is 9 volts. I is 18 thousandths of an amp. Therefore, R equals 9 divided by 18 thousandths, or R equals 500 ohms. So, if an LED is equivalent to 111 ohms, how much extra resistance do we need to add to the LED in the circuit so that we get a flow of 18 milliamps with a 9-volt battery? Since with a 9-volt battery we need 500 ohms to cause a current of 18 milliamps, the fact that our LED is equivalent to 111 ohms, we need 500 ohms less 111 ohms, which is equal to 389 ohms. Therefore, we need to add a resistor of 389 ohms in series with the LED and the 9-volt battery. Well, let me say, that's one way to find the correct resistor value to put in series with the LED and a battery. Now let me tell you a quicker way to determine the value of the resistance needed in the circuit with an LED. It would be to use this formula. R equals E divided by I, where R is the unknown resistance needed, E is the voltage drop across the unknown resistance, and I is the amount of current allowed in the circuit. Here we have a simple circuit showing an LED, an unknown resistor, and a battery. If the battery is 9 volts and the LED drops 2 volts, the unknown resistor would have to drop the other 7 volts. So, using R equals E divided by I as we explained, we have 7 volts drop across the unknown resistor divided by the current in the circuit of 18 milliamps, or 18 thousandths of an amp, that the LED requires. That would give R is equal to 7 volts divided by 18 thousandths of an amp, or 389 ohms. Let's try it with a 12-volt battery. If the voltage drop across the LED is 2 volts, then the voltage drop across the unknown resistor would have to be 10 volts. Putting those numbers into the formula, we get R equals E divided by I. R equals 10 volts divided by 18 thousandths. So R, the unknown resistor, equals 556 ohms. So we need to put a 556 ohm resistor in series with the LED and the 12-volt battery. Note, in electronics, the values can be close and still work just fine. You actually don't need to find a 556 ohm resistor. Something close to that will work just fine. I would suggest that we use a 470 ohm resistor because 470 ohm resistors are common and easy to find, and it will work just fine in this circuit. Go ahead and finish this lesson by answering the question and filling in the schematic on page 18B of your lab manual. Upon completion of that, you're ready to go to lesson 19.